Grandfather Paradox. Imagine a scenario where time travel is possible and you have a time machine. You decide to travel back in time to meet your grandfather when he was a young man. However, things take a dramatic turn. While you're in the past, you accidentally prevent your grandfather from meeting your grandmother. This means your parents were never born, and consequently, you were never born. Here's the twist. If you were never born, how could you have traveled back in time to prevent your grandfather from meeting your grandmother? If you never existed, you couldn't have gone back in time to create this situation in the first place. This creates a logical contradiction because your actions in the past seem to negate your own existence. This is known as the Grandfather Paradox. It's a classic problem in discussions about time travel and causality. The paradox challenges our understanding of cause and effect, and it raises questions about the consistency of time and the possibility of altering the past. To visualize this paradox, think of it like this. If you could go back and change events in a way that prevents your own existence, you create a situation where you shouldn't have been able to make those changes. This creates a paradox where the cause, your time travel, contradicts the effect, your existence. The Grandfather Paradox is not just a theoretical puzzle. It has significant implications for our understanding of time travel. If such time travel were possible, it could lead to contradictions and complex issues regarding causality and the flow of time. The Grandfather Paradox leads to intriguing questions about the nature of time and reality. If time travel to the past could result in such paradoxes, what does this mean for the possibility of traveling back in time? One common response to the paradox involves the concept of parallel universes, or alternate timelines. According to this theory, if you were to travel back in time and alter events, you would create a new parallel timeline where the changes take place. In this new timeline, your actions would have prevented your own existence in that specific timeline, but it wouldn't affect the original timeline you came from. In this way, the Grandfather Paradox is resolved by suggesting that time travel creates branching timelines rather than altering a single, fixed timeline. Each timeline remains consistent within its own context, avoiding contradictions by separating the changes into different realities. Another approach to addressing the paradox is the idea of time loops or closed time-like curves. This theory suggests that events in the past are part of a closed loop, meaning that any actions you take when traveling back in time are already accounted for in the timeline. Essentially, you might find that you cannot change significant events in the past because they are already integrated into the timeline. In this view, the paradox is resolved by the idea that the timeline is self-consistent. Your actions, even if they seem to contradict the possibility of your existence, are part of a larger, unchangeable loop of events that doesn't allow for contradictions. The Grandfather Paradox also prompts discussions about the limitations of our understanding of time and causality. It challenges our intuitive notions of cause and effect and forces us to reconsider how we think about the flow of time and the possibility of altering past events. The Grandfather Paradox is more than just a philosophical puzzle. It has implications for various fields, including physics, philosophy, and even popular culture. The paradox stimulates discussions about the nature of time, causality, and the feasibility of time travel. In physics, the paradox raises questions about the consistency of physical laws and the possibility of time travel. While many theories, such as Einstein's theory of relativity, allow for the theoretical possibility of time travel, they also imply constraints that could prevent paradoxes like the Grandfather Paradox from occurring. For example, some physicists argue that certain conditions, such as the need for infinite energy or closed time-like curves, may prevent paradoxical scenarios. Philosophically, the paradox challenges our understanding of determinism and free will. If time travel were possible, it could lead to questions about whether our actions are predetermined or whether we have the freedom to alter the course of events. The paradox forces us to grapple with the implications of altering past events and the potential consequences for our understanding of reality. In popular culture, the Grandfather Paradox has inspired numerous works of fiction, from novels to movies, exploring the complexities and consequences of time travel. These fictional portrayals often play with the paradox in creative ways, highlighting the challenges and potential solutions to time travel dilemmas. Looking ahead, the grandfather paradox remains a valuable thought experiment for exploring the boundaries of our understanding of time and reality. While time travel remains a theoretical concept, the paradox provides insights into the challenges and limitations that would arise if such phenomena were possible. In summary, the grandfather paradox is a compelling puzzle that prompts us to reconsider our notions of time, causality, and the nature of reality. By examining the paradox and its implications, we gain a deeper understanding of the complexities associated with time travel and the broader philosophical questions it raises. Bootstrap Paradox. Imagine receiving a book filled with revolutionary ideas only to discover that it was written by you, except you haven't written it yet. Now imagine you travel back in time and give this book to your younger self. Your younger self uses it to write the book in the future. The question is, where did the book actually come from? This is the Bootstrap Paradox, one of the most mind-bending concepts in time travel, where an object or piece of information exists without any clear point of origin. It loops endlessly through time, defying our understanding of cause and effect. The Bootstrap Paradox is named after the idea of pulling yourself up by your own bootstraps, a phrase meant to describe something that seems impossible. In this paradox, something creates itself. It exists because it was sent back in time, but its origin remains a mystery. It's a paradox that forces us to question the very nature of time, causality, and reality. To make it simpler, let's break it down with a classic example. Imagine a scientist in the future invents a time machine. They travel back in time and meet their younger self, giving them the detailed blueprints for building the time machine. The younger self uses these blueprints to build the machine and eventually grows up to become the same scientist who travels back in time. But here's the problem. Where did the original idea for the time machine come from? It wasn't invented. It was simply passed around in an endless loop. The machine exists, but it has no true beginning. This paradox challenges one of our most fundamental assumptions about reality, that every effect must have a cause. In the Bootstrap Paradox, the cause and effect are tangled in such a way that they become indistinguishable. The time machine exists, but its origin is stuck in a loop, forever recycling itself. What makes the Bootstrap Paradox so fascinating is that it's not just a thought experiment. It has implications for how we understand time and causality. In our everyday experience, time flows in one direction, from past to present to future. Cause leads to effect, and actions have consequences. But in a time travel scenario, these rules break down. The past can influence the future, but the future can also influence the past, creating a feedback loop where the origin of events becomes impossible to trace. Philosophically, the Bootstrap Paradox raises profound questions about free will and determinism. If the blueprints for the time machine have no origin, does that mean the scientist's actions are predetermined by the loop? Or is the paradox itself a demonstration of how free will can exist outside of linear causality? The paradox forces us to confront the possibility that time isn't as straightforward as it seems, that it might be a much more flexible and interconnected phenomenon. Science fiction often explores the Bootstrap Paradox in creative ways. One famous example is the movie Terminator. In the film, a character travels back in time to protect a future leader, but in doing so, becomes part of the events that lead to that leader's rise. Another example is the classic time travel novel, The Time Traveler's Wife, which plays with the idea of a self-contained loop in which events happen because they've already happened. These stories highlight the paradox's strange and captivating nature, inviting us to imagine a reality where time is anything but linear. From a scientific perspective, the Bootstrap Paradox is tied to theories about time travel, particularly in the context of general relativity. Einstein's equations allow for the possibility of closed time-like curves, essentially loops in space-time where events can circle back on themselves. While this idea remains theoretical, it suggests that the paradox might not just be a product of imagination, but a potential feature of the universe itself. But here's where it gets even more interesting. The Bootstrap Paradox isn't just about time travel. It's about information and causality. Imagine a piece of information, like a scientific formula or a historical event, that exists solely because it was sent back in time. Who created it? If the information has no origin, does it really exist? This idea challenges our understanding of knowledge and creation, blurring the lines between what is real and what is merely a product of the loop. The Bootstrap Paradox also has profound implications for how we think about the universe as a whole. If time can loop back on itself, it raises the possibility that the universe itself might be a self-contained system with no clear beginning or end. In this view, the Big Bang might not be the start of everything, but just one part of a larger, cyclical process. The paradox forces us to question whether anything truly has an origin, or if everything is part of an interconnected web of cause and effect. So is the Bootstrap Paradox solvable? Not within the framework of linear time and causality as we currently understand them. The paradox exists precisely because it defies resolution, challenging us to think beyond our normal assumptions about time and logic. It's not a problem to be solved, but a question to be explored, a doorway into a deeper understanding of the mysteries of time, causality, and existence. The Bootstrap Paradox reminds us that the universe is far stranger and more complex than we often realize. It invites us to imagine realities where beginnings and endings blur, where cause and effect intertwine, and where time itself bends in ways that defy comprehension. And perhaps that's the most profound lesson of the paradox, that even in a world bound by logic and rules, there will always be mysteries that leave us wondering, paradoxes that push us to question, to explore, and to dream. Twin paradox. Time travel may sound like science fiction, but there's a paradox that brings it shockingly close to reality. The twin paradox, a thought experiment from Einstein's theory of relativity, challenges our very understanding of time, space, and how they interact. It's not just a fascinating riddle. It's a glimpse into the mind-bending world of modern physics, where time can stretch, shrink, and behave in ways that defy intuition. The twin paradox begins with a simple premise. Two identical twins. One twin stays on Earth, living their everyday life, while the other boards a spacecraft that travels close to the speed of light. After completing their journey through space and returning to Earth, something extraordinary happens. The traveling twin is younger than the one who stayed behind. How is this possible? They're twins, after all. They started with the same age. Shouldn't they have experienced time in the same way? The answer lies in Einstein's theory of special relativity, which describes how time and space are interconnected. One of the key principles of relativity is that time is not absolute. Instead, it's relative to the observer's motion. This means that the faster you move, especially at speeds approaching the speed of light, the slower time passes for you compared to someone who isn't moving as fast. This phenomenon is known as time dilation, and it's at the heart of the twin paradox. For the twin aboard the spacecraft, time moves more slowly because of their incredible speed. To them, the journey might feel like only a few years have passed. But for the twin on Earth, where time moves at its usual pace, decades could have gone by. When the traveling twin returns, they find their sibling significantly older, while they have barely aged. This isn't just a theoretical idea. It's a real effect that has been observed in experiments involving particles traveling at high speeds. At first glance, the paradox seems to raise a symmetry problem. If motion is relative, can't the traveling twin argue that it was their sibling who was moving while they stayed still? Why should the traveling twin age more slowly? The resolution to this lies in the fact that the two twins experience different paths through space-time. The traveling twin undergoes acceleration and deceleration as they leave Earth, turn around, and return. This breaks the symmetry of the situation. In contrast, the twin on Earth remains in a single, inertial frame of reference, experiencing no such changes in motion. The twin paradox isn't just a thought experiment, it has practical implications. In fact, time dilation is a measurable effect. For example, GPS satellites orbiting Earth experience time dilation because of their high speeds and the weaker gravity at their altitude. To ensure that GPS systems work accurately, scientists have to account for this effect, adjusting the satellite clocks so they stay in sync with clocks on Earth. Without this adjustment, your GPS navigation would quickly become unreliable. The paradox also challenges our everyday assumptions about time. We tend to think of time as a constant, ticking away at the same rate for everyone, everywhere. But the twin paradox reveals that time is far more flexible than we imagine. It can stretch and compress depending on your speed and location in the universe. This isn't just an abstract idea. It's a reality that has been confirmed by countless experiments and observations. The implications of the twin paradox extend beyond physics, touching on deep philosophical questions about time and existence. What does it mean for two people to experience time differently? How does relativity reshape our understanding of aging, identity, and memory? And if time itself can behave so strangely, what other surprises might the universe hold? One of the most fascinating aspects of the twin paradox is how it bridges the gap between science fiction and science fact. Concepts like time travel, interstellar exploration, and life at near light speeds often seem fantastical. But the paradox shows us that these ideas are grounded in the fundamental laws of physics. It's not a question of whether time dilation is real. It's a question of how we might one day use it to explore the cosmos. Yet the paradox also serves as a humbling reminder of the limits of human intuition. Our brains evolved to understand a world where speeds are slow, distances are short, and time feels constant. The twin paradox pushes us beyond these everyday experiences, forcing us to think in terms of a universe that operates on entirely different scales. It's a testament to the power of human curiosity and imagination, allowing us to glimpse a reality that lies far beyond our senses. So, what does the twin paradox teach us? It's more than just a quirk of physics. It's a profound insight into the nature of time and space. It challenges us to rethink what we know about reality, to question our assumptions, and to embrace the strange and wondrous truths of the universe. And perhaps most importantly, it reminds us that even the most familiar concepts, like time, can hold mysteries that are waiting to be discovered. Pinocchio Paradox. What happens when Pinocchio says, "My nose will now grow"? Will it grow or will it not? At first glance, this might sound like a clever riddle, but it's actually a deep philosophical and logical puzzle known as the Pinocchio Paradox. It challenges our understanding of truth, lies, and self-reference in a way that is both deceptively simple and profoundly mind-bending. Let's start with Pinocchio's unique situation. He's a wooden puppet brought to life, and his nose grows every time he tells a lie. Now, if Pinocchio says, "My nose will now grow," we're caught in a paradox. If his nose does grow, it means he was telling the truth. But if he was telling the truth, his nose shouldn't grow, because it only grows when he lies. On the other hand, if his nose doesn't grow, it means he was lying. But if he was lying, his nose should grow. No matter how you approach it, Pinocchio's statement creates a logical contradiction that cannot be resolved. This paradox belongs to a family of self-referential puzzles, much like the famous Liar's Paradox, where someone says, "This sentence is false." Both paradoxes highlight the challenges of self-reference, where a statement refers to itself in a way that creates a loop of contradiction. But the Pinocchio Paradox has a unique twist. It ties this logical contradiction to a physical consequence, making it feel more tangible and even more perplexing. To fully appreciate the Pinocchio Paradox, we need to explore what makes it so puzzling. The key lies in the relationship between truth, lies, and cause and effect. In Pinocchio's world, lies have a direct, measurable outcome. His nose grows. This cause and effect relationship seems straightforward until you introduce a self-referential statement like, "My nose will now grow." At that point, the logic breaks down, because the outcome determines the truth of the statement. But the truth of the statement also determines the outcome. It's a feedback loop that defies resolution. What makes the Pinocchio Paradox so fascinating is how it challenges the way we think about language and reality. In our everyday lives, we rely on language to describe the world around us. Statements are either true or false, and we assume there's a clear distinction between the two. But the Pinocchio Paradox shows that this distinction isn't always so clear. When language refers to itself, it can create situations where truth and falsehood blur together, leaving us with no clear answers. Philosophically, the Pinocchio Paradox raises profound questions about the nature of truth and meaning. What does it mean for a statement to be true or false? Can something be both true and false at the same time? These questions have been debated by philosophers for centuries, and the Pinocchio Paradox brings them into sharp focus. It forces us to confront the limits of our understanding and consider the possibility that truth might be more complex than we often assume. The paradox also has implications for logic and mathematics, particularly in the study of formal systems. In the early 20th century, mathematician Kurt Gödel proved that any sufficiently complex formal system contains statements that cannot be proven true or false within the system itself. The Pinocchio Paradox is a playful reminder of this limitation, showing how self-reference can create problems that defy resolution. But the Pinocchio Paradox isn't just an abstract puzzle. It also has real-world relevance. It highlights the challenges of dealing with self-referential systems, which appear in fields ranging from computer science to law. For example, a computer program that tries to analyze its own code can run into loops or contradictions, much like Pinocchio's statement. Similarly, legal systems sometimes create rules that conflict with themselves, leading to situations where it's impossible to determine the correct outcome. The paradox also has a psychological dimension. It reflects the human tendency to overanalyze and second-guess ourselves, especially when faced with complex or contradictory situations. Just as Pinocchio's statement ties itself in knots, our own thoughts can sometimes create mental loops that are difficult to escape. The paradox serves as a reminder to approach such situations with curiosity and humility, recognizing that not every problem has a clear or simple solution. So, what can we learn from the Pinocchio Paradox? First, it teaches us to question our assumptions about truth, logic, and language. It shows that even the most basic ideas can become profoundly complex when viewed from a new perspective. Second, it challenges us to think critically about self-reference and the limitations of our understanding. And finally, it reminds us that paradoxes aren't just problems to be solved. They're opportunities to explore the mysteries of thought, language, and reality. In the end, the Pinocchio Paradox isn't just about a wooden puppet with a growing nose. It's a doorway into some of the deepest questions about how we make sense of the world. It invites us to embrace complexity, to think beyond the surface, and to see the beauty in the puzzles that make life so endlessly fascinating. So the next time you hear Pinocchio say, "My nose will now grow," remember, it's not just a clever riddle, it's a journey into the very heart of logic and meaning. Sword and Shield. Paradox. Imagine a merchant boasting about his incredible weapons. "This sword," he says, "is so sharp it can cut through anything." Then he picks up a shield and declares, "And this shield is so strong it can block any attack." A curious onlooker raises a hand and asks, "What happens if your sword strikes your shield?" The merchant freezes, realizing the contradiction. This is the Sword and Shield Paradox, also known as the paradox of the irresistible force and the immovable object. It's a thought experiment that seems simple, but reveals profound truths about logic, language, and the limits of absolute claims. The paradox originates from ancient China, where a merchant's exaggerated claims about his unbeatable sword and unbreakable shield were met with the same question: what happens when they meet? The paradox highlights an inherent contradiction. Both claims can't be true at the same time. If the sword can cut through anything, it must pierce the shield. But if the shield can block anything, it must stop the sword. The two absolute qualities cancel each other out, creating an impossible situation. On the surface, this seems like a clever puzzle, but it's more than that. The Sword and Shield Paradox forces us to confront the limitations of absolutes. Absolute claims like, "This sword can cut through anything," or "This shield can block anything," are appealing because they sound definitive and powerful. But when two absolutes collide, they expose the flaws in their logic. The paradox reminds us that the world is rarely as black and white as absolute statements make it seem. One of the most interesting aspects of the sword and shield paradox is how it applies to real-world situations. Think about debates or arguments where two opposing ideas claim to be entirely correct. For example, what happens when the need for absolute security collides with the demand for absolute freedom? Both ideals sound appealing on their own, but when pushed to their extremes, they can't coexist. The paradox shows us the value of nuance and compromise, reminding us that absolutes are often unrealistic in a complex world. The paradox also has implications for logic and reasoning. It exposes the limits of systems that rely on contradictions. In formal logic, statements that contradict themselves are considered invalid or nonsensical. The sword and shield paradox illustrates this by creating a scenario where language breaks down. If a sword can cut through anything and a shield can block anything, the words anything lose their meaning when applied together. The paradox challenges us to think critically about the assumptions and definitions we use in reasoning. Philosophically, the paradox raises questions about the nature of power and limits. What does it mean for something to be truly unstoppable or immovable? In physics, for example, the idea of an irresistible force meeting an immovable object is often used as a metaphor for conflicting principles. But in reality, the concept doesn't make sense within the laws of the universe. If such a force and object existed, one would cancel out the other, showing that even in theory, absolutes have boundaries. The sword and shield paradox also has a psychological dimension. It reflects the human tendency to make exaggerated claims or seek certainty in an uncertain world. Whether it's advertising, politics, or personal beliefs, we often encounter statements that promise absolutes. The paradox teaches us to approach these claims with skepticism, recognizing that the truth is often more complex than it appears. Interestingly, the paradox is closely related to other famous thought experiments, like the liar's paradox, where a statement contradicts itself. This sentence is false. Both paradoxes reveal how language and logic can create situations that defy resolution. They challenge us to question the way we think and communicate, showing that even the most straightforward ideas can lead to profound puzzles. So, what's the solution to the sword and shield paradox? The short answer is that there isn't one, not within the framework of the paradox itself. The contradiction is built into the scenario, making it impossible to resolve without abandoning one of the claims. This lack of resolution is what makes the paradox so powerful. It forces us to confront the limitations of our understanding and embrace the complexity of the world. The sword and shield paradox isn't just a quirky puzzle. It's a tool for critical thinking. It reminds us to question absolutes, seek nuance, and recognize the limits of logic and language. In a world that often values certainty and simplicity, the paradox encourages us to embrace ambiguity and complexity, showing that the most interesting questions are often the ones without clear answers. In the end, the sword and shield paradox isn't about weapons or warriors. It's about the collision of ideas, the nature of contradiction, and the search for truth. It challenges us to think beyond the surface, to question what we take for granted, and to see the world not in absolutes, but in possibilities. And perhaps that's the greatest lesson of all, that true understanding comes not from resolving paradoxes, but from learning to live with them. Dichotomy Paradox. Imagine you're about to walk across a room. Simple, right? But before you can reach the other side, you have to cover half the distance. Then, to cover the remaining half, you have to travel half of that distance, and then half of that, and so on. Suddenly, you're trapped in an infinite series of steps, each smaller than the last. If you can't complete an infinite number of tasks, how can you ever reach the other side? Welcome to the Dichotomy Paradox, one of the most famous thought experiments introduced by the ancient Greek philosopher Zeno of Elea. At first glance, the paradox seems absurd. Of course, we can cross the room. We do it every day without a second thought. But the Dichotomy Paradox challenges us to think more deeply about the nature of motion, infinity, and how we understand the passage of time and space. Zeno's paradox has fascinated thinkers for centuries because it asks a question that seems simple but reveals profound complexities about the way the universe works. Let's break it down. The paradox starts with the idea that to move from point A to point B, you must first reach the halfway point. But to get to the halfway point, you must first reach the quarter point. And to get there, you must reach the eighth point, and so on. This creates an infinite sequence of smaller and smaller steps that you must complete. The problem is that completing an infinite number of tasks seems impossible. If there are infinitely many steps, how can motion ever occur? How can you ever take the first step, let alone reach your destination? The paradox highlights a fascinating conflict between our everyday experience and the logical implications of dividing space and time into infinitely small parts. In reality, we have no trouble crossing rooms, walking down streets, or traveling great distances. But Zeno's paradox forces us to confront a deeper question. How do we reconcile the idea of infinite divisibility with the fact that motion clearly happens? One way to approach this is through the concept of an infinite series. Mathematically, the distances described in the paradox, half, then a quarter, then an eighth, and so on, form a convergent series. When you add up all these fractions, their sum approaches a finite number, the total distance between point A and point B. In other words, even though the series involves infinitely many terms, the total distance remains finite. This mathematical insight resolves the paradox on a practical level, showing that the infinite steps Zeno describes can indeed be completed in a finite amount of time. But Zeno's dichotomy paradox isn't just a mathematical puzzle, it also raises philosophical questions about the nature of reality. If space and time can be infinitely divided, does that mean they're made up of infinitely small parts? Or is there a fundamental limit to how far we can divide them? These questions lie at the heart of debates about the nature of the universe, from ancient philosophy to modern physics. In the 20th century, quantum mechanics and relativity added new layers to this discussion. Quantum mechanics suggests that space and time may not be infinitely divisible, but instead have a smallest possible unit, known as the Planck length and Planck time. These fundamental limits challenge the idea of infinite divisibility and offer a potential resolution to Zeno's paradox on a physical level. If there's a smallest possible step, then the infinite sequence of smaller and smaller steps described in the paradox simply doesn't exist in the real world. At the same time, Einstein's theory of relativity revolutionized our understanding of space and time by showing that they're not separate entities but part of a single, interconnected fabric. Motion, according to relativity, is not about objects moving through absolute space, but about changes in the relationships between objects in space-time. This perspective shifts the focus of Zeno's paradox, suggesting that motion might be better understood as a continuous process rather than a series of discrete steps. The dichotomy paradox also has implications for how we think about infinity itself. Infinity is a concept that challenges human intuition. It's not just a very large number, but a fundamentally different kind of quantity. Zeno's paradox forces us to confront the idea that infinity can appear in the smallest details of motion, as well as in the vastness of space and time. It reminds us that even the most ordinary experiences, like walking across a room, can contain mysteries that stretch the limits of our understanding. But perhaps the most profound lesson of the dichotomy paradox is what it reveals about the relationship between logic and reality. On a purely logical level, the paradox suggests that motion is impossible. Yet we know from experience that motion happens all the time. This tension highlights the limitations of human reasoning and the importance of testing ideas against the real world. It reminds us that while logic and mathematics are powerful tools for understanding the universe, they're not the whole story. Zeno's dichotomy paradox is more than just a thought experiment. It's a gateway to some of the deepest questions about the nature of reality, motion, and infinity. It challenges us to think critically about the assumptions we take for granted and to explore the mysteries hidden in everyday experiences. And perhaps that's why it continues to captivate us, because it shows us that even the simplest act of crossing a room can open the door to an infinite world of possibilities. Simpsons Paradox. Imagine two treatment options for a life-threatening disease. You're told treatment A has a higher success rate than treatment B, so you confidently choose treatment A. But later, you learn that when you break the data into subgroups, say younger and older patients, treatment B actually performs better in both groups. How can treatment B be better in every subgroup, but treatment A still has a higher overall success rate? This is Simpsons Paradox, a statistical phenomenon that defies intuition and reveals the surprising ways data can mislead us. At its core, Simpsons Paradox occurs when trends that appear in different groups of data disappear, or even reverse when the groups are combined. It's a paradox that challenges our understanding of statistics and forces us to rethink how we interpret information. To make this clearer, let's dive into an example. Imagine a university that is evaluating its admission rates for male and female applicants. The data shows that overall, a higher percentage of male applicants were admitted compared to female applicants, suggesting potential gender bias. But when you break the data down by departments, you discover that each department actually admitted a higher percentage of female applicants than male applicants. How is this possible? The answer lies in the composition of the data. In this scenario, the paradox occurs because women apply disproportionately to highly competitive departments with low admission rates, while men applied more often to less competitive departments with higher admission rates. When the data is aggregated, these differences skew the overall results, creating the illusion of bias against women, even though no such bias exists within individual departments. This paradox is a reminder of the dangers of oversimplifying data. It highlights the importance of context and shows how combining or aggregating data can mask important details. In the example of the university admissions, the overall numbers told one story, but the departmental breakdown told a very different one. Simpsons Paradox teaches us that the way we group and analyze data can fundamentally change the conclusions we draw. The implications of Simpsons Paradox go far beyond hypothetical examples. It appears in real-world scenarios across a wide range of fields, from medicine and social science to sports and public policy. For instance, in clinical trials, a treatment might seem effective when the results are aggregated but turn out to be less effective or even harmful when analyzed for specific subgroups such as age or gender. In politics, aggregated voting data can suggest trends that don't hold true within individual demographics. Even in business, marketing campaigns or product evaluations can be misleading if the data isn't analyzed carefully. The paradox also raises deeper questions about causality and decision-making. When faced with contradictory patterns in data, how do we determine which perspective is correct? Should we focus on the overall trend, or should we prioritize the subgroup analysis? The answer often depends on the context and the questions we're trying to answer. Simpsons Paradox reminds us that data doesn't speak for itself. It requires interpretation, and that interpretation can be influenced by how the data is presented and understood. One of the most important lessons of Simpsons Paradox is the need for critical thinking and careful analysis. In a world increasingly driven by data, it's easy to take numbers at face value, especially when they confirm our assumptions or fit a compelling narrative. But Simpsons Paradox shows that data can be more complex than it appears, and that even seemingly straightforward statistics can be deceptive. This paradox also has profound implications for how we communicate data. Misleading interpretations of data can have serious consequences, from flawed medical decisions to misguided policies. Understanding Simpsons Paradox can help us become more discerning consumers of information, better equipped to ask the right questions and challenge misleading conclusions. Simpsons Paradox also reminds us of the importance of transparency in data analysis. When presenting data, it's essential to provide enough context and detail to allow others to understand how the data was collected, grouped, and analyzed. Aggregated results can be useful, but they should always be accompanied by a breakdown of subgroups to avoid oversimplification and misinterpretation. Philosophically, Simpsons Paradox challenges us to think about the nature of truth and perception. It reveals how different perspectives on the same data can lead to conflicting conclusions, forcing us to grapple with the idea that truth is often more nuanced than we'd like to believe. It's a paradox that invites us to embrace complexity and to question our assumptions about the way the world works. In the end, Simpsons Paradox isn't just a quirk of statistics. It's a powerful reminder of the importance of context, critical thinking, and curiosity. It teaches us to look beyond the surface, to dig deeper into the data, and to approach information with a healthy dose of skepticism. And in a world where data increasingly shapes our decisions, that lesson might just be one of the most life-changing paradoxes of all. Paradox of the Raven. If someone told you that looking at a green apple could prove that all ravens are black, you'd probably think they were joking. But that's exactly what the paradox of the raven suggests, and it's one of the most mind-bending puzzles in logic and philosophy. How can something as unrelated as the color of an apple tell us anything about ravens? This paradox forces us to question not only how we think about evidence, but also how we understand the way knowledge works. The paradox of the raven, also known as Hempel's paradox, was introduced by the German philosopher Carl Gustav Hempel in the 1940s. It starts with a simple statement: all ravens are black. In logic, this is equivalent to saying, if something is not black, then it is not a raven. These two statements mean the same thing. They're logically interchangeable. But here's where things get strange. If you want to prove that all ravens are black, you might think the best way to do that is to observe lots of black ravens. And that's true. Each black raven you see adds evidence to the claim. But by the same logic, observing something that is not black and is not a raven, like a green apple, also counts as evidence for the statement, all ravens are black. Why? Because a green apple fits the idea that if something is not black, it's not a raven. So, according to the rules of logic, spotting a green apple provides just as much evidence for the claim as spotting a black raven. This is the paradox of the raven. It challenges our intuition by suggesting that evidence for a statement can come from observations that seem completely unrelated. At first, this idea feels absurd. How can looking at an apple tell us anything about ravens? The paradox arises because of the way logical equivalence works. If the statement, all ravens are black, is true, then so is its contrapositive. If something is not black, then it is not a raven. Any observation that fits the contrapositive, like a green apple, logically supports the original statement. But our intuition rebels against this. We feel that looking at a raven tells us more about ravens than looking at an apple does. The paradox reveals a disconnect between formal logic and human intuition. In logic, all evidence that supports a statement is equally valid, no matter how it's obtained. But in practice, we assign different weights to different types of evidence. Seeing a black raven feels like strong evidence for the claim, all ravens are black, while seeing a green apple feels irrelevant, even though both are logically equivalent. To make sense of this, let's dig deeper into the nature of evidence. When we evaluate evidence in the real world, we're not just thinking about logical equivalence. We're also considering how informative or specific the evidence is. A black raven is directly related to the claim, so it feels highly relevant. A green apple, on the other hand, doesn't seem to tell us much about ravens, even if it technically supports the statement. This highlights a key limitation of formal logic. While it provides a framework for reasoning, it doesn't always align with how we process information or assign significance to evidence. The paradox of the raven also raises questions about the limits of scientific observation. In science, we often gather evidence to test hypotheses, much like observing black ravens to support the claim, all ravens are black. But the paradox reminds us that evidence is rarely straightforward. It challenges us to think critically about how we interpret observations and whether our methods of reasoning truly capture the complexity of the world. Interestingly, the paradox has parallels in other areas of philosophy and science. In epistemology, the study of knowledge, it forces us to confront the problem of induction, how we justify generalizing from specific observations. In probability theory, it relates to Bayesian reasoning, which assigns probabilities to hypotheses based on prior knowledge and new evidence. These connections show that the paradox of the raven isn't just an abstract puzzle, it's a window into some of the deepest questions about how we understand the world. The paradox also has a psychological dimension. It reveals how deeply our intuitions about relevance and causality shape our reasoning. We naturally prioritize evidence that feels connected to the claim we're evaluating, even if other evidence is equally valid in a logical sense. This highlights the importance of being aware of our cognitive biases and questioning our assumptions about what counts as evidence. So, what can we take away from the paradox of the raven? First, it reminds us to think critically about the nature of evidence and how we evaluate it. It challenges us to question our intuitive judgments and consider the role of logic in shaping our understanding. Second, it highlights the complexity of knowledge and the limitations of formal reasoning. And finally, it encourages us to embrace paradoxes as opportunities for growth, pushing us to explore the boundaries of our thinking and uncover new insights. In the end, the paradox of the raven isn't just a puzzle about apples and ravens. It's a profound exploration of how we reason, learn, and seek truth. It invites us to look beyond the surface, to question our assumptions, and to embrace the unexpected connections that shape our understanding of the world. So the next time you see a raven, or even a green apple, remember, both are part of a larger story about how we make sense of the universe. And perhaps that's the most life-changing paradox of all. Grain of millet paradox. If a single grain of millet falls, does it make a sound? What about a handful of grains? Or an entire sack? This simple yet profound question is at the heart of the grain of millet paradox, a thought experiment that challenges our understanding of perception, scale, and the nature of change. It forces us to confront a fascinating problem. How do tiny, seemingly insignificant actions combine to create something noticeable or even monumental? The grain of millet paradox originates from the ancient Greek philosopher Zeno, who was famous for posing questions that defy intuition. The paradox is deceptively simple. A single grain of millet falling to the ground seems too small to make a sound. But if we multiply this action, a handful of grains, or a sack full of them, they clearly produce a sound. So when does the transition happen? At what point does something that appears silent become audible? The paradox forces us to think about how small, incremental changes contribute to larger effects, and where we draw the line between something and nothing. To truly understand the grain of millet paradox, let's unpack its deeper implications. At first glance, the paradox seems like a question about sound and perception, but it's really about continuity and thresholds, how individual parts contribute to a whole. The grain itself represents a small, seemingly insignificant unit, and the sound it makes is so faint it's imperceptible. But when enough grains fall, they collectively create a noise that's undeniable. The paradox highlights the disconnect between individual units and the collective outcome they produce. This idea extends far beyond sound. Think about a pile of sand. If you add one grain at a time, it's hard to say when the collection of grains becomes a pile. Similarly, when you remove grains one by one, at what point does it stop being a pile? The grain of millet paradox belongs to a family of puzzles known as Sorite's paradoxes, which explore how small, incremental changes lead to significant shifts. These paradoxes force us to confront the ambiguity of thresholds and challenge the precision of the categories we use to define the world. Philosophically, the grain of millet paradox raises questions about perception and experience. If a single grain falling doesn't make a sound we can hear, does that mean the sound doesn't exist? This touches on broader debates in epistemology, the study of knowledge, and the role of human perception in defining reality. Are things real only when we perceive them, or do they exist independently of our senses? The paradox nudges us to consider whether small, imperceptible phenomena are just as real as those we can observe. The paradox also has a practical dimension, particularly in the context of cumulative effects. Think about climate change. One person driving a car or using plastic might seem insignificant, but when billions of people do the same, the impact becomes undeniable. The grain of Millet paradox reminds us that even the smallest actions can accumulate into something powerful. It's a call to think critically about how individual choices add up and to recognize the collective impact. Riddle. It's a riddle. It's a solutions. The paradox even applies to personal growth and habits. Imagine trying to learn a new skill, like playing the piano or learning a language. Practicing for a single day might not seem to make a difference, but practice consistently over weeks, months, or years, and the results are transformative. The grain of Millet paradox teaches us the importance of persistence and patience, showing that small, consistent efforts can lead to profound change. But the paradox isn't just a lesson in accumulation. It's also a reminder of the limits of human perception. Our senses aren't perfect. They have thresholds below which we fail to notice things. A single grain of millet might make a sound, but it's too faint for us to hear. This raises intriguing questions about what else we might be missing. What phenomena, too small, too slow, or too subtle, exist beyond the range of our senses, shaping the world in ways we can't perceive? In modern science, this idea has fascinating parallels. In quantum mechanics, for example, particles behave in ways that are invisible to the naked eye, but have profound effects on the physical world. In biology, the behavior of a single cell might seem inconsequential, but together, cells form tissues, organs, and entire organisms. The grain of Millet paradox reminds us that the world operates on multiple scales, and what seems insignificant at one level can be transformative at another. The paradox also has ethical implications. In a world facing collective challenges like inequality, environmental degradation, and public health crises, it's easy to feel that individual actions don't matter, but the grain of Millet paradox reveals the power of accumulation. One act of kindness, one vote, or one effort to reduce waste might feel small, but multiplied by millions, these actions can change the world. The paradox challenges us to reconsider the significance of our choices and to recognize the ripple effects of even the smallest contributions. So what's the takeaway from the grain of Millet paradox? First, it teaches us to pay attention to the small things, the grains of millet, the drops of water, the moments of effort that shape our world in profound ways. Second, it reminds us of the interconnectedness of individual actions and collective outcomes. And finally, it encourages us to embrace complexity, recognizing that change often happens not in giant leaps, but in the steady accumulation of tiny steps. The grain of Millet paradox isn't just a philosophical puzzle. It's a powerful lens for understanding the world. It challenges us to think critically about perception, thresholds, and the cumulative power of small actions. And perhaps its greatest lesson is this: in a universe where even the faintest sound of a falling grain can add to the symphony of existence, nothing is truly insignificant. Every grain matters, and so do you. Obers Paradox. Look up at the night sky. It's filled with stars, but there's so much darkness between them. Have you ever wondered why? If the universe is infinite and filled with stars, shouldn't the sky be blazing with light, with no room for darkness? This is Obers Paradox, a mystery that has puzzled scientists and philosophers for centuries. It's a question that seems simple, but leads to profound insights about the nature of the universe, its age, and its structure. The paradox is named after Heinrich Wilhelm Olbers, a 19th-century German astronomer who popularized the idea, though versions of it had been discussed earlier. At its core, the paradox asks this: if the universe is infinite, eternal, and uniformly filled with stars, then every line of sight should eventually land on the surface of a star. This would mean that the entire night sky should glow as brightly as the surface of the sun. But instead, we see vast stretches of darkness. Why? To understand why this is such a puzzle, imagine standing in a dense forest. No matter which direction you look, your line of sight eventually lands on a tree trunk. In an infinite universe filled with stars, the same logic should apply. Every direction should lead to the surface of a star. Yet the night sky is mostly dark. This contradiction between theory and observation is what makes Olbers' paradox so fascinating. For centuries, scientists proposed different explanations. One idea was that dust and gas in space might block the light from distant stars, preventing it from reaching us. But this doesn't work. Over time, interstellar dust would heat up and begin to glow, filling the sky with light anyway. Another suggestion was that the stars might simply be too far away, with their light dimming as it traveled across vast distances. But in an infinite universe, the number of stars increases without limit, meaning their combined light should overcome any dimming. These early attempts to solve the paradox only deepened the mystery. The breakthrough came in the 20th century, with the discovery that the universe is neither infinite nor eternal in the way previously imagined. Instead, it has a finite age, around 13.8 billion years, and it's expanding. These two facts are key to resolving Obers Paradox. First, let's consider the universe's age. If the universe is 13.8 billion years old, then light from stars more than 13.8 billion light-years away hasn't had enough time to reach us. The finite age of the universe limits the number of stars we can see, creating gaps of darkness in the sky. In other words, the observable universe is not infinite. It's bounded by the speed of light and the universe's age. Second, the universe's expansion plays a crucial role. As the universe expands, the light from distant stars and galaxies is stretched into longer wavelengths, a phenomenon known as redshift. This stretching moves the light out of the visible spectrum, making it invisible to the human eye. What we perceive as darkness is often light that has shifted into infrared or radio wavelengths. These two insights, the finite age of the universe and its expansion, transform Obers' paradox from a mystery into a powerful tool for understanding the cosmos. They reveal that the dark night sky is not a flaw in the universe's design, but a window into its history and structure. But the paradox doesn't end there. It also raises deeper philosophical and existential questions. The darkness of the night sky reminds us that the universe is vast, and much of it lies beyond our ability to perceive. It's a humbling realization, forcing us to confront the limits of human knowledge and the scale of the cosmos. Interestingly, what we do see when we look at the night sky is evidence of the universe's origins. The faint glow of the cosmic microwave background radiation, remnants of the Big Bang, fills the sky, even in its darkest parts. This background radiation is a direct result of the universe's finite age and expansion, providing a subtle but profound answer to Obers' paradox. It's a reminder that the darkness we see isn't empty. It's filled with the story of the universe's birth and evolution. Obers' paradox also highlights the interconnectedness of science. Solving it required insights from astronomy, physics, and cosmology, showing how different fields come together to answer fundamental questions. It's a testament to the power of human curiosity and our ability to piece together the mysteries of the universe. So what does Obers' paradox teach us? First, it reminds us to question our assumptions. The idea of an infinite, eternal universe seemed intuitive for centuries, but closer examination revealed its flaws. Second, it shows us the value of looking beyond the surface. The darkness of the night sky isn't just absence, it's evidence of the universe's dynamic history. And finally, it inspires us to keep exploring, to push the boundaries of what we know, and to embrace the wonder of the unknown. In the end, Obers' paradox is more than just a question about the night sky. It's a journey into the nature of existence itself, challenging us to think deeply about the universe and our place within it. So the next time you look up and see the darkness between the stars, remember, that darkness is not just the absence of light. It's a doorway to understanding the cosmos. Card Paradox. Picture holding a simple card with two statements written on either side. On one side, it says, "The statement on the other side of this card is true." When you flip it over, the other side says, "The statement on the other side of this card is false." At first, this might seem like a harmless little puzzle, but as you start to think it through, you quickly realize something astonishing. It doesn't make sense. This is the card paradox, a thought experiment that challenges our understanding of truth, logic, and self-reference. The card paradox belongs to a family of puzzles known as self-referential paradoxes. These are scenarios where a statement refers to itself in a way that creates a logical contradiction. The paradox on the card works like this. If the statement on the first side is true, the statement on the other side is true, then the statement on the other side is false, must also be true. But if that's true, then the first statement must be false. And if the first statement is false, then the second statement becomes false as well, looping us back to the first. It's a never-ending cycle of contradictions with no resolution. At its core, the card paradox forces us to confront the limits of our logical systems. Our brains are wired to think in terms of true and false, yes and no. But self-referential paradoxes like this one reveal that even the simplest logical structures can break down when they turn inward on themselves. The card paradox isn't just a quirky brain teaser. It's a profound challenge to the way we think about truth and meaning. To understand why this paradox is so significant, let's dig deeper into what it teaches us about logic. In formal systems, a statement is typically either true or false. This is known as the law of the excluded middle. But the card paradox defies this principle by creating a situation where neither truth nor falsehood seems to apply. Instead, the statements feed into each other in an endless loop. This breakdown of logic is what makes the paradox so intriguing and so unsettling. One of the most famous self-referential paradoxes, the liar's paradox, works in a similar way. It's the statement, "This sentence is false." If the sentence is true, then it must be false. But if it's false, then it must be true. Like the card paradox, the liar's paradox reveals the fragility of logical systems when faced with self-reference. The card paradox takes this idea a step further by involving two statements that rely on each other, rather than a single statement referring to itself. Philosophers and logicians have grappled with these kinds of paradoxes for centuries. In the early 20th century, the mathematician Kurt Gödel made a groundbreaking discovery. Any sufficiently complex formal system contains statements that are true but unprovable within the system itself. Gödel's incompleteness theorems, as they're called, show that no logical system can be both complete and consistent. The card paradox is a playful example of this principle, highlighting the inherent limitations of logical reasoning. But the implications of the card paradox go beyond formal logic. It also raises fascinating questions about language and meaning. When we communicate, we rely on shared definitions and assumptions to convey ideas. But the card paradox demonstrates how language can create contradictions that defy resolution. It's a reminder that even the words and concepts we take for granted can break down under close scrutiny. The paradox also has psychological dimensions. It forces us to confront uncertainty and ambiguity, two things that humans are notoriously uncomfortable with. Our natural instinct is to resolve contradictions and find clarity. But the card paradox denies us that resolution, leaving us in a state of cognitive dissonance. This can be frustrating, but it's also an opportunity to expand our thinking and embrace complexity. So, what can we learn from the card paradox? First, it teaches us to question our assumptions about truth and logic. It shows that even the most basic ideas can become deeply complex when viewed from a new perspective. Second, it challenges us to think critically about self-reference and the ways it shapes our understanding of the world. And finally, it reminds us to embrace ambiguity as a natural part of life. Not every question has a clear answer, and sometimes the journey of exploring a paradox is more valuable than resolving it. The card paradox isn't just a clever puzzle, it's a gateway to some of the deepest questions about logic, language, and the human mind. It invites us to think beyond binary categories, to explore the limits of knowledge, and to appreciate the beauty of contradictions. So the next time you see a simple card with two statements, remember, it's not just a piece of paper. It's an invitation to expand your understanding of the universe. And that's a paradox worth pondering. Stockdale Paradox. Imagine enduring years of unimaginable suffering and coming out not just intact, but stronger. How would you do it? This is the heart of the Stockdale Paradox, a concept that reveals the delicate balance between hope and brutal realism. Named after Admiral James Stockdale, a U.S. Navy officer and prisoner of war in Vietnam, This paradox challenges conventional wisdom about optimism, resilience, and survival. The Stockdale Paradox originates from Stockdale's harrowing experience as a POW during the Vietnam War. For 8 years, he endured brutal torture, isolation, and uncertainty. Many of his fellow prisoners didn't survive, succumbing to despair or broken spirits. But Stockdale did. And when asked how, his response revealed a paradox that has since inspired leaders, psychologists, and thinkers alike. The optimists, Stockdale said, were the ones who didn't make it. They were the ones who said, "We'll be out by Christmas." And Christmas would come, and Christmas would go. Then they'd say, "We'll be out by Easter." And Easter would come, and Easter would go. And then Thanksgiving, and then it would be Christmas again, and they died of a broken heart. Stockdale explained that survival wasn't about blind optimism or wishful thinking. It was about holding two seemingly contradictory ideas in your mind at the same time. Unwavering faith that you will prevail in the end, and the discipline to confront the brutal facts of your current reality. This is the Stockdale Paradox, the ability to balance hope with realism, to maintain faith in the future while not denying the challenges of the present. It's a paradox because it goes against what we often think of as positive thinking. Blind optimism can lead to disillusionment when reality fails to meet expectations. But at the same time, losing hope entirely can be equally destructive. The paradox lies in finding the equilibrium between these two extremes. Let's explore why this mindset is so powerful. On one hand, having faith in a better future gives you the motivation to keep going. Without hope, despair takes over, making it difficult to endure hardship. But on the other hand, denying the harshness of your circumstances can leave you unprepared for the challenges ahead. By embracing the brutal facts of your situation, you build resilience and develop strategies to survive, even if those strategies are painful or difficult. The Stockdale Paradox shows us that hope and realism aren't opposites. They're complementary forces. In Stockdale's case, this paradox played out in a literal life-and-death scenario, but its lessons extend far beyond the battlefield. In business, relationships, and personal growth, the Stockdale Paradox teaches us how to navigate adversity. For example, in the face of a failing project, blind optimism might lead you to ignore warning signs and press on without a plan, while pure pessimism might cause you to give up entirely. The Stockdale Paradox suggests a third path, acknowledging the challenges while maintaining faith in your ability to find a solution. This mindset is particularly relevant in times of crisis, whether it's a global pandemic, an economic downturn, or a personal struggle. When the future feels uncertain, it's tempting to either cling to false hope or sink into despair. The Stockdale Paradox reminds us to do neither. Instead, it calls us to face the reality of our circumstances head-on while holding on to the belief that we can overcome them. Psychologists have found that this approach aligns with the concept of adaptive resilience. Resilient people don't deny the difficulties they face, but they also don't let those difficulties define them. They adapt, finding ways to grow and persevere even in the darkest times. The Stockdale Paradox captures this balance perfectly, showing that resilience isn't about avoiding pain. It's about enduring it with purpose. The paradox also highlights the dangers of false hope. Stockdale's fellow prisoners who clung to unrealistic timelines were devastated when those timelines came and went. Their misplaced optimism left them unprepared for the long haul. This doesn't mean we should avoid hope altogether. It means we need to ground our hope in reality. Hope that is tethered to a clear-eyed view of the situation becomes a source of strength, not weakness. But the Stockdale Paradox isn't just about surviving adversity. It's about thriving through it. Stockdale didn't just endure his time as a prisoner of war. He emerged from it with a deeper understanding of himself and the world. He found meaning in his suffering, using it to grow and to inspire others. This is a crucial part of the paradox, the idea that even in the darkest moments, we can find purpose and meaning that carry us forward. So how can we apply the Stockdale Paradox to our own lives? First, we need to practice radical honesty about our circumstances. This means confronting the facts, no matter how uncomfortable they are. Denial might feel easier in the short term, but it leaves us vulnerable in the long run. Second, we need to cultivate a deep and abiding faith in our ability to overcome challenges. This isn't blind optimism. It's a belief rooted in the knowledge that we are capable of enduring and adapting. The Stockdale Paradox also calls us to develop emotional flexibility. It's not about suppressing fear or despair, but about allowing those emotions to coexist with hope and determination. This balance requires self-awareness and reflection, as well as a willingness to embrace discomfort as part of the journey. In the end, the Stockdale Paradox isn't just a lesson in survival. It's a blueprint for living a meaningful life. It teaches us that the human spirit is capable of incredible resilience when we balance hope with realism, faith with action, and optimism with pragmatism. It reminds us that even in the face of immense suffering, we can find strength, purpose, and growth. So the next time you face a challenge that feels overwhelming, remember the wisdom of Admiral Stockdale. Hold on to the belief that you will prevail, but never shy away from confronting the truth of your situation. Because in that delicate balance lies the power to not just survive, but to thrive. And that's the paradox's greatest lesson, that hope and honesty together are the keys to enduring life's greatest tests. Service Recovery Paradox. Picture this. You go to a restaurant, and your order is completely messed up. Frustrating, right? But then something unexpected happens. The staff apologizes sincerely, replaces your meal with a perfect one, offers you a free dessert, and even gives you a voucher for your next visit. Suddenly, your perception of the restaurant has skyrocketed, and you leave feeling more loyal than if the mistake had never happened. This is the Service Recovery Paradox, a fascinating phenomenon that reveals how a failure, when handled correctly, can actually improve customer satisfaction and loyalty. The Service Recovery Paradox challenges the traditional idea that businesses succeed by avoiding mistakes at all costs. Instead, it suggests that mistakes, when addressed with exceptional recovery efforts, can turn into opportunities to strengthen customer relationships. It's not about the mistake itself. It's about how the business responds. Let's break this down. At its core, the Service Recovery Paradox hinges on two factors: the emotional impact of the mistake and the effectiveness of the recovery effort. When something goes wrong, customers naturally feel disappointed, frustrated, or even angry. But when a company goes above and beyond to fix the issue, it triggers a powerful emotional response. The customer feels valued, respected, and reassured. This emotional recovery can sometimes leave the customer more satisfied than if nothing had gone wrong in the first place. Here's a simple example. Imagine booking a hotel room only to find that your room isn't ready when you arrive. Annoying, right? But now picture this. The hotel staff apologizes profusely, upgrades you to a suite, offers you free room service, and ensures the rest of your stay is flawless. Suddenly, your initial frustration is replaced with gratitude, and you're likely to remember the experience as overwhelmingly positive. In this way, the failure becomes a moment to showcase the company's commitment to excellence. But here's where it gets tricky. The Service Recovery Paradox doesn't mean that businesses should intentionally make mistakes to impress customers with their recovery efforts. That would be a dangerous gamble. First, not all customers respond positively to recovery attempts. Some may still feel frustrated or decide to take their business elsewhere. Second, repeated mistakes, even with stellar recoveries, can erode trust over time. The paradox works best when failures are rare and recovery efforts are exceptional. The paradox also depends on the nature of the mistake and the context in which it occurs. For instance, minor, easily fixable errors, like a delayed order or a billing mistake, are more likely to lead to the Service Recovery Paradox than major failures, like a flight cancellation during a family emergency. In the latter case, even the best recovery effort may not fully repair the emotional damage caused by the failure. So, why does the Service Recovery Paradox work? One reason is that it taps into the psychology of expectations. When something goes wrong, customers' expectations plummet. They anticipate excuses, delays, or indifference. A thoughtful and proactive recovery effort defies these low expectations, creating a sense of surprise and delight. This emotional contrast enhances the customer's perception of the business, often leading to greater loyalty and advocacy. Another reason lies in the concept of reciprocity. When a company makes a genuine effort to fix a mistake, customers often feel a sense of obligation to respond positively. It's human nature. When someone goes out of their way to help us, we tend to appreciate it and want to reciprocate, whether through loyalty, positive reviews, or recommendations. The service recovery paradox also highlights the importance of trust. When a company successfully recovers from a mistake, it demonstrates reliability, accountability, and a willingness to put the customer first. This builds trust, which is the foundation of long-term relationships. Customers feel confident that even if something goes wrong in the future, the company will take care of them. But the paradox isn't a free pass for businesses to be careless. To leverage the power of the service recovery paradox, companies need to approach service failures strategically. First, they must listen and empathize with the customer's experience. A sincere apology is often the first step in rebuilding trust. Second, they need to act quickly and decisively to resolve the issue. Speed and efficiency signal to the customer that their concerns are a priority. Finally, businesses should go above and beyond to make amends, whether through compensation, personalized gestures, or simply exceeding expectations. The paradox also highlights the value of empowering employees to handle service recovery. Frontline staff are often the first point of contact when things go wrong, and their ability to empathize, problem solve, and act decisively can make all the difference. Training employees to respond effectively to service failures is an investment that pays off in customer satisfaction and loyalty. The service recovery paradox isn't just a strategy for businesses. It's a powerful reminder of the human capacity for resilience and growth. It shows that mistakes, while inevitable, don't have to define us. Instead, they can be opportunities to demonstrate integrity, build trust, and strengthen relationships. Whether in business or in life, how we respond to failure matters just as much, if not more, than the failure itself. In the end, the service recovery paradox is more than just a tool for customer retention. It's a profound insight into the nature of human relationships, showing that trust and loyalty are built not by avoiding mistakes, but by handling them with care, empathy, and excellence. So the next time you encounter a service failure, whether as a customer or a business, remember, every mistake is an opportunity to create something better. And that's a paradox worth embracing. Paradox of enrichment. Consider you're running a wildlife reserve, and your goal is to protect a predator-prey relationship. You decide to enrich the prey population, make the habitat better, provide more food, ensure their numbers grow. You'd expect this to strengthen the ecosystem, right? But instead, disaster strikes. The predator population skyrockets. They overconsume the prey, and the entire system collapses. This is the paradox of enrichment, a concept from ecology that reveals how attempts to improve a system can unintentionally destabilize it. The paradox, first introduced by ecologist Michael Rosenzweig in 1971, describes how increasing the food supply for prey species can lead to ecological collapse. At its heart, it's a counterintuitive lesson about balance, sustainability, and unintended consequences. While it originates in ecology, its implications extend far beyond the natural world, offering profound insights into economics, human behavior, and the systems we rely on. Here's how the paradox of enrichment works in nature. Imagine a simple predator-prey system: rabbits and foxes. If you introduce more food for the rabbits, lush grass, better conditions, you might expect the rabbit population to thrive, providing a stable and plentiful food source for the foxes. But in reality, the opposite often happens. The rabbits multiply rapidly, and the foxes take advantage of this abundance to increase their numbers as well. The problem is that the foxes grow too numerous, consuming rabbits faster than they can reproduce. Eventually, the rabbit population crashes, and with no food left, the foxes crash too. What started as an effort to strengthen the ecosystem ends in its collapse. The paradox highlights the delicate balance that ecosystems depend on. Predators and prey are locked in a dynamic relationship, each influencing the other's population. By enriching the system beyond its natural equilibrium, we unintentionally create instability. It's a stark reminder that nature doesn't always respond to intervention the way we expect. But the paradox of enrichment isn't just an ecological curiosity. It's a broader metaphor for how well-intentioned efforts can backfire in complex systems. Take economics, for example. Imagine a government trying to stimulate growth by flooding the market with resources, subsidies, or incentives. At first, the economy booms, but soon imbalances emerge: overproduction, inflation, or resource depletion. Just like in an ecosystem, enrichment destabilizes the system. The paradox also appears in human behavior. Consider the idea of overindulgence. If you want to motivate a team or encourage a child, you might think providing more rewards, more praise, more treats would increase their performance. But too much enrichment can lead to complacency or dependency, undermining the very goal you set out to achieve. The lesson here is clear. More isn't always better. Sometimes, striving for improvement without understanding the underlying system can lead to unintended harm. In a world of peace of mind, progress, the paradox of enrichment serves as a cautionary tale. It challenges the assumption that adding more to a system will always make it stronger. Instead, it urges us to think critically about balance, sustainability, and the unintended consequences of intervention. The paradox also raises profound philosophical questions about human interaction with the natural world. In our efforts to control and improve ecosystems, economies, and societies, how often do we disrupt the very systems we're trying to protect? The paradox of enrichment invites us to reflect on our role as stewards of the planet and to consider the limits of our understanding. It reminds us that complexity requires humility, and that even the best intentions can lead to unforeseen outcomes. One way to address the paradox is to focus on resilience rather than enrichment. Instead of trying to maximize a single element of a system, like prey populations or economic output, we can work to maintain the system's overall stability. In ecology, this might mean protecting biodiversity and natural habitats, rather than artificially boosting one species. In human systems, it could mean prioritizing long-term sustainability over short-term gains. The paradox of enrichment also teaches us to embrace uncertainty. Complex systems, whether ecosystems, economies, or societies, are full of interdependencies that we can't always predict. By recognizing these complexities, we can approach problems with a mindset of curiosity and caution, avoiding the pitfalls of overconfidence and oversimplification. Ultimately, the paradox of enrichment isn't just about nature. It's about the interconnectedness of all systems. It shows us that even small changes can have ripple effects, and that our actions, no matter how well-meaning, can produce unintended consequences. It challenges us to think critically, act thoughtfully, and respect the delicate balances that sustain life on Earth. So the next time you're faced with a problem, whether it's ecological, economic, or personal, remember the lesson of the paradox of enrichment. Sometimes the best way to strengthen a system isn't to add more. It's to understand what makes it stable in the first place. Because in the end, true enrichment comes not from overloading a system, but from honoring its complexity and finding harmony within it. Paradox of lottery. Imagine you've just purchased a ticket for an enormous lottery drawing. The chances of winning are incredibly slim. Let's say a mere 1 in 10 million. Despite the overwhelming odds stacked against you, you find yourself filled with excitement and hope. Curiously, when you hold that ticket in your hand, there's a sense of confidence that you just might be the lucky winner. This personal conviction seems oddly rational, even in the face of such astronomical odds. Now, let's expand our perspective. In a massive lottery where each ticket has an infinitesimal chance of winning, every single ticket holder can maintain a sense of optimism about their own prospects. This intriguing phenomenon is known as the paradox of the lottery. The crux of this paradox lies in the stark contrast between the statistically high likelihood of losing and the individual's personal belief that they might emerge victorious. The paradox becomes even more fascinating when we consider the collective outcome. Despite each individual ticket holder nurturing the belief that they might win, The reality is that only one ticket, or perhaps a handful at most, will actually clinch the prize. This creates a striking logical inconsistency. How can we reconcile the fact that so many people harbor the belief that they will win when statistically the vast majority are destined to lose? To illustrate the paradox more vividly, let's envision a lottery with 10 million tickets in circulation. Each ticket carries a 1 in 10 million chance of winning. If every single ticket holder maintains the belief that they will be the fortunate winner, their conviction appears wildly irrational given the overwhelming odds. However, on a personal level, it's somewhat understandable. Each individual is unlikely to contemplate the probability of the entire group losing. Instead, they focus solely on their own ticket and its potential. This paradox shines a spotlight on the intriguing conflict between personal belief and collective statistical reality. It demonstrates how individuals can simultaneously hold seemingly contradictory views. They can believe in their own chance of winning while acknowledging that the majority of ticket holders will inevitably face disappointment. Let's delve deeper into the intricacies of the paradox of the lottery by examining the fascinating interplay between individual belief and statistical reality. Each lottery participant's conviction that they might win is deeply rooted in their personal investment in the outcome. Even though they are intellectually aware of the minuscule probability of winning, their hope burns bright and remains intensely personal. This deeply held personal belief stands in stark contrast to the cold, hard statistical reality. From a purely mathematical standpoint, if there are 10 million tickets in circulation and only one ultimate winner, the probability of winning with any given ticket is astonishingly low. Yet, remarkably, this statistical fact seems to have little impact on the optimistic outlook maintained by each ticket holder. One illuminating approach to understanding this paradox is to consider the concept of subjective versus objective probability. Subjective probability refers to the personal belief or confidence an individual holds regarding an outcome, while objective probability represents the actual mathematical likelihood of an event occurring. In the context of the lottery, the subjective probability for each ticket holder is heavily influenced by their hope and personal investment in the outcome. This subjective perspective can lead to the seemingly irrational belief that their particular ticket somehow possesses a better chance of winning than it objectively does. Conversely, the objective probability reflects the true, exceedingly small chance of winning. This stark disparity between subjective belief and objective probability lies at the heart of the paradox. Individuals cling to their personal chances of success, despite being aware of the statistical odds, resulting in an apparent contradiction. The paradox extends beyond mere improbability of winning. It delves into the very nature of rationality in personal belief when confronted with overwhelming odds. The paradox also intersects with fascinating cognitive biases and psychological factors that shape human decision-making. People often exhibit a tendency to overestimate their own chances of success in scenarios with low probabilities, a phenomenon psychologists refer to as the optimism bias. This cognitive bias helps explain why individuals can maintain a rational belief in their potential to win even when the odds are overwhelmingly stacked against them. The paradox of the lottery opens up a Pandora's box of intriguing questions about human psychology, decision-making processes, and belief systems. It challenges our fundamental understanding of how individuals perceive probabilities and make choices based on those perceptions. One significant implication of this paradox is that it underscores the limitations inherent in purely rational decision-making models. Traditional rational models operate under the assumption that individuals make decisions based solely on objective probabilities. However, the paradox of the lottery vividly demonstrates that personal beliefs and psychological factors can exert a powerful influence on decision-making, often leading to behavior that appears irrational when viewed through the lens of statistical reality. This paradox also carries broader implications for our understanding of how people navigate risk and uncertainty in various aspects of life. Beyond the realm of lotteries, individuals frequently encounter situations where the probability of a desired outcome is extremely low. yet their personal belief in a positive result remains steadfast. This phenomenon can significantly influence behavior across diverse domains, including gambling, investment decisions, and even health-related choices. Another fascinating aspect of the paradox is its relevance to ongoing discussions in the fields of probability theory and decision theory. It highlights the complexity involved in aligning subjective beliefs with objective probabilities and poses a challenge to traditional models that assume purely rational decision-making processes. Ultimately, the paradox of the lottery serves as a powerful reminder of the profound influence that hope and personal belief exert in shaping human behavior. Despite the cold, hard statistical odds, individuals' beliefs and emotions play a pivotal role in their decision-making processes. By grappling with this paradox, we gain a deeper appreciation for the intricate and often surprising relationship between probability, belief, and human behavior. In conclusion, the paradox of the lottery offers a captivating exploration of the tension between personal belief and statistical reality. It challenges our conventional understanding of probability, decision-making, and human psychology, providing valuable insights into the complex ways in which we perceive and respond to uncertainty in our lives.